today's webcast, Smart Energy, Water, and Wastewater Management, and a special thank you to today's sponsor, GE Vernova. We are excited to be joined by our presenters today, Benjamin Whiteman and Prasad Pai. With a background in supply chain and manufacturing, Ben Whiteman is the lead product manager for circularity and sustainability at GE Digital. He brings a visionary and grounded approach to software innovation in digital manufacturing. He has managed, analyzed, and optimized manufacturing in food and beverage and consumer packaged goods. He now works with GE's extensive customer base in diverse industries to help them meet their sustainability goals. Ben is a practiced systems thinker with a passion for architecting circular, regenerative, and equitable industrial processes that drive multidimensional business value at a local and global scales. Prasad, the Senior Director of Product Management at GE Digital, has over 30 years helping align industrial, customer, and partner needs with software product and platform value. Prasad is a proven leader that follows a customer and partner-centric approach to product management, product marketing, industry segmentation, market strategies, and product value creation. And thank you to them both for being with us today. I'm going to go ahead and I'm going to turn it over to you, Ben.
Thank you. So we're going to start today talking about, I thought it'd be interesting to share with the audience some of the kind of global context around energy, water, wastewater, and then we'll kind of narrow the funnel down and talk more specifically. So in my role, I talk with customers in quite a wide variety of industries. And one of the common challenges that we hear from customers is the role of energy. Not only is it ubiquitous in most industrial facilities, not only is it required to run most machinery and processes that our customers use, but the costs are increasing tremendously in recent years in response to different geopolitical tensions, in response to the increasing trend toward electrification and the global energy transition. And energy costs are becoming incredibly expensive, but also volatile. And while energy understandably gets a lot of attention, given its penetration in our lives and for its role in carbon emissions, many of our customers in the water wastewater space, as well as those who are industrial water users, are confronted by challenges with respect to the water that they distribute, manage, rely on, either to produce their products or to run their facilities. And many of our customers are finding themselves operating now in water-stressed regions. And the costs with managing those risks are high, and they're expected to continue to increase in future years as weather patterns change, as water management practices change, and as policies emerge and change as well. And some of those policies, in response to these resource supply risks, in response to drought and increasing water risk, we're seeing a lot of jurisdictions adopt new policies around resource management, particularly around water, around reducing waste and driving for greater utilization of these resources through circular economic models and circularity policies. And I'll speak a bit more about that if that's unfamiliar later in the presentation. But we expect these are only going to continue to grow in importance and in prevalence. And beyond the importance of water itself, the management and distribution of water is incredibly important in abating these issues. Project Drawdown, which is quoted here, is a leading climate solutions research organization. And their research on managing water systems and controlling leaks clearly shows the tremendous climate impact that good management and technology-enabled management of water can provide. So I'll now turn it over to Prasad, who will talk about maybe some of the more specific challenges to the water wastewater space. Prasad, over to you.
Sure. Thank you, Ben. And before we get into more of the circularity aspects of it and how what's the opportunity and what can we do and understand the circular water cycle there, I think let's what I wanted to do was spend some time on the current challenges and goals with water wastewater utilities. I From what we see talking to our customers, talking to just participating in industry think groups, there are three. Usually, it's kind of the challenges around water wastewater is around these three pillars, which is making sure there is a continued service. There's an increasing reliability in how the operations occur. There's obviously a reduction of cost that goes in, but those could be a variety of different aspects in terms of where the cost comes in. Ben talked about energy. There is a significant amount of cost that goes into the chemical usage for treatment. It's just we're seeing more and more customers now focusing on what they call as non-revenue water, which is really the leakage that happens as water travels through the systems, and the water that is lost that cannot be billed by these utilities to consumers or to industrial customers, as an example. And then you know the bigger aspect of operating a utility, operating what we call as a critical infrastructure, is really the minimization of the risk. So whether it is non-compliance in terms of the EPA standards, whether it is the security risks, and whether it's any of the environmental risk based on the amount of chemicals that are pumped in, or any of the spillage that happens from all of the treatment that happens there. So these are kind of the goals that on a day-to-day basis, when I think of a typical water wastewater customers, that's what they think of. And as there have been several customers who have kind of moved towards trying out analytical solutions, trying out what we call as smart technologies, to see if they can solve some of these challenges that they have. But what we are seeing from different analysts that are analyzing the market, different studies that are conducted, that only about 12% of the utilities really see themselves as early adopters. A very large part of the industry is still catching up from technologies implemented back in the early 2000s. There are some utilities who are even in the 1990s in terms of the technology that has been put in when the utility first came online. So there's a lot of struggle in terms of just getting more to the current standards of what is available in the market in terms of the solutions that they implement. When we look at, one of the reasons why Ben was also focused on energy, and he'll talk a little bit more about the circular aspects of water treatment here. Almost 25 to 40% of the energy used by municipalities is in treating of the water. And it's related to the pumps that are operated, and the pumps, whether they are the most efficient ones based on maintenance, or they kind of draw a lot of energy. There's a significant amount of cost that goes into that. And here's a quick study. I'm not going to spend a whole lot of time. Here's a quick study on just the cost that a water utility goes through when it comes to potable water treatment, right? As you see, energy and chemicals are significant amount of costs, and there are efforts going on. There are certain utilities who are further ahead than others in terms of technology adoptions, have tried different solutions. And one of the things we wanted to bring forth is just examples of what can be done. What is the opportunity to get to what we call as smart resource management when it comes to the water wastewater industry. So just a few examples before I turn it over to Ben for circularity. Um, as we look at smart resource management, everything that starts from a solution standpoint starts with data. And water wastewater systems as implemented today all water wastewater customers store data, they collect data, they're trying to find ways in terms of gathering more data about their systems. I think where the difference between water utilities that are further ahead in terms of their solutions versus water utilities that are kind of lagging in some of these efforts is really what have they done with the data, or how well is the data accessible to the people that really spend time analyzing these different systems. And that's where the difference lies. And that's why when we talk about data, it's not for the lack of collection of data or the amount of data that is stored from the operations. It's really, can can you make sense of that data? Is it stored in a way that that can be accessed by higher level systems, or can be accessed by people who can make sense of the data? And that's where the journey really begins of smart resource management. And as we think of most utilities, it's a cycle as you see all of these systems being implemented. A large part, I would say almost 90% of our water wastewater customers are at the basic controls level. That's where their focus is. That's where whenever there's a budget, it's easier. It's a capital budget. That's where they spend most of their money on to ensure they put in cybersecurity practices. They put in the latest of controls. They they ensure that the controls are reliable, the system is up and running, and providing water to consumers at a continuous basis, and good clean water is obviously the focus. Um, Slowly the industry is starting to realize that there is also a cost saving to be had if we can start to analyze this information, if we can start to operate more efficiently, if we can start to predict some of what may be causing efficiency failures, or what may be causing increased energy usage as you treat water. And that is the journey that water, I would say water utilities are just beginning. And one of the thing obviously is the fact that a lot of these water utilities lack the skill set when it comes to implementing analytics. A lot of water utilities, even when I think about our municipal customers, a lot of these customers even struggle trying to get budgets to implement such projects, because it's kind of hard to definitively define what is going to be the cost saving, or what is going to be the benefit, or how does it improve the eventual supply of clean water. And this is where we kind of work with a lot of our industry friends here to help them kind of understand what are the possibilities, where can you improve, what are based on the age of the infrastructure they have, based on the systems they have, based on the size of the system they have, even based on the number of consumers they serve, and the intake that comes in, or the dynamics of the chemistry of the water that they deal with. There are many such opportunities that you can utilize some of the smarts to get to a smart resource management. And what I wanted to do here, again, before we get into circularity, is really look at some simple things, some low-hanging fruit that our friends in the water industry can do. Now, this is a very simple use case around a pump that goes into a treatment station. Um, I think most of you would have seen this happen, where over a period of time, as you see wastewater pumps, their efficiency starts to go down, or due to corrosion, there are bolts that wear off, and which causes a breakdown in the pump. And some of the problems with these pumps could just be that it's downtime, and there's usually with water wastewater, there are spare pumps that you operate, but it's a cost and it's a downtime. And while if the pump has not gone bad, if the efficiency is down, it starts to draw a lot more energy. So the question is, how do you start to detect that this is what is happening? So as you start to collect data, as you start to understand the behavior of the pump, you start to look at the pump curves of how the pump is operating, and this is where analytics can help. And this is where knowing what data that is getting stored from the pump or what data would be needed to get into such kind of analytics is also important. And that's where customers, in fact, a lot of the data is collected. There may be certain things that from an input standpoint already comes in from the pump, but it is not looked at in the systems. It's not collected. It's just informational for a lot of water customers. So just knowing what is possible, and this is where when you think of simple algorithms, and this could be all of us are very familiar with AI ML today. A lot of customers have been asking us about, can Chat GPT help us with some of this? Well, at some point in time, obviously for analytics to work, as I said, the data has to work. We have to ensure that the data is there. But as you start to analyze some of this, the analytics can start to compare a normal behavior of the pump with the existing behavior of the pump, and it can start to predict the anomaly. You can set at what point does the analytics start to flag an anomaly, so you are more proactive in maintaining the pump, or you are more proactive in cleaning out the pump or looking at what's going, and that can help with uh, improving the age of the pumps. It can help improve maintain a better efficiency that reduces the energy usage as well. And these are just examples, simple examples that customers have used. And there are various tools out there. I mean, it's there's no one analytic that does this better than the others. A lot of it again depends on the resources that the water utility has, either within their own engineering teams or with the system integrators or the engineering firms that they work with. Looking at what resources they have, you can go with the analytical models that starts to look at your history, but then it also starts to do a comparison of your historical model with the real-time information that you're starting to get from this information as well. There are some other use cases. Again, some are analytical, some are more data access related. This is an example of just accessibility of data, right? And this could be in terms of making sure that operators in the field have the ready access. They have the right level of notifications. There are work instructions that they can look at. Work instructions are part and parcel of the system. So if there's an alarm, if there's an intrusion alarm, if there's a leak, if there's a pump break, then if your system also provides on-the-go instructions of what to do next for operators, that can save time, that can save money. You can guide the operator to take the right action at the right time, reducing the angst and the cost of that downtime that may occur. So accessibility of the data is important. There are customers we know who have implemented systems that they call as smart sewer, basically looking at how do you do stormwater management. And this is not a normal use case for a water utility to think of. Most of the thought goes into treatment of the water, or most of the thought goes into distribution of the water and ensuring that the tanks are filled, and in the 4 a.m. in the morning, when someone turns on the tap, there's good clean water coming to the consumer. But these are important aspects, because stormwater management can lead to efficiency in terms of how reduce flooding, or just seepage into your water system can be avoided if stormwater management is done done correctly. And that can lead to, and these are not short-term solutions. This is not something that you implement and you start to see a cost benefit immediately. But over a period of time, you start to realize the savings, the cost savings in terms of treatment, in terms of just the overall energy optimization that happens across the system. This is not one pump, two pumps. This is a overall system related related benefit that you get out of some of these solutions. So the idea behind kind of presenting these use cases is, as you think about sustainability, as you think about circularity within water wastewater, a lot of times we think of sustainability as a metric that only applies in manufacturing, or that is something where consumers who consume finished goods in food and beverage, or the material that, or products that you use from CPG, that's where there is a focus on sustainability, and consumers are a lot more active, and you start to see employees of those companies being a lot more active in driving sustainability. But what a lot of people miss is the fact that there is an opportunity for the utilities to contribute as well, and a significant part of the energy, a significant part of the cycle of sustainability can be driven through the utilities itself. Now, this is again an example of just reducing the operating costs, or reducing the quality discharge that happens from a EPA compliance standpoint, of solutions that people put in place. And this goes beyond just the control systems. And the idea behind presenting these use cases is to show the opportunity outside of just basic control system, basic operations of treatment plants and water distribution, to see what is possible where there can be efficiencies, there can be opportunity for sustainability. And with this, I'll turn it over to Ben, who will kind of go into a little more detail about what does circularity in water look like, and how it matters, and why some of these solutions kind of eventually would play into that role as well.
Thanks, Prasad. Yeah, and Prasad makes a great point that considering the actions that can be taken, the opportunities in considering how your operation can be more sustainable, not only drives maybe improvements in efficiency, but also they have direct relationships to your cost basis, to your P&L, and that reconsidering how your organization can leverage digital tools to drive more efficient utilization of resources, smart resource management, leveraging data management, systems modeling, predictive analytics to more efficiently manage those resources and the assets that move them, or that are required in those processes, drives cost efficiency as well. So circular systems are another way to improve resource utilization and reduce costs. And when circular systems are implemented with these software, with these predictive analytics, with powerful data management systems, the results can be even more impactful. But let me take a step back for a moment. If you're unfamiliar with what I'm talking about when I say circular systems, or if you've never heard of what's termed the circular economy, the circular economy is a systems solution framework. It's aimed at changing the way our supply chains are currently constructed, but truly changing how we use and manage resources more generally. And currently, we take materials, we extract them, we make products out of them, or we use them for a purpose, and then they're discarded in some way. And the circular economy aims to shift that paradigm and create systems which capture products at the end of their use, or at the end of their life. and direct them back into the economy through reuse, repair, remanufacturing, or recycling. And in the water space, this is just as applicable as it is in the manufacturing space. If we think about recapturing water at the end of its use and redirecting it back into the system, circular systems provide a focus on maximizing the utilization of that material. And in the previous slide, you saw an example, an early example of a circular system in place in Kalundborg, which is an industrial park in a town in Denmark. And the energy and water and material that were used in one facility were matched with the needs of another facility or another use case. You can imagine how that might apply in the water space, where we're taking water that's been used for one application and we're cascading it to another application, ultimately getting greater value out of the same material, out of the same water stream, which ultimately reduces both the demand, the net system inputs required, but also the waste that's generated. So opportunities to actually implement this. Some of these things might seem a bit idealistic, but there are real opportunities to capture and create value, oftentimes reduction in cost or increase in revenue, by looking for ways to adopt circular principles. Those things could be cascading gray water from one application to the next, finding opportunities to recover materials, for example, biosolids, or leveraging waste materials, biosolids, for energy generation that can offset some of the costs of operating. So there are real examples in which chemicals, for example, can be recaptured. Fertilizers is a great example of this, and then resold. So there are very tactical examples in which applying circular systems in the water wastewater space can not only create efficiencies that improve costs, but also in some cases drive value creation and drive greater revenue. But how do you begin? Beginning is often really, really challenging in these larger systemic paradigm shift type initiatives. And many of our customers are adopting circular resource management goals in order to improve their environmental impact, in order to reduce waste and costs, in order to increase the utilization of resources. But acting on those initiatives, acting on those goals is extremely challenging. And digitization can be a crucial enabler in moving from a goal, an idea that sounds great in theory, to a practice and a policy that drives it on your plant floor or in your facility. This is especially true for industrial water users. Measuring these flows, collecting the data on the quality of the water, the composition and the quantity, is a key first step in creating greater utilization of those streams. And it's foundational to optimizing the utilization of that water. It's also important is defining the requirements for use at each point water is needed in the system, so that applications using water inputs can be matched with outflows that have the appropriate characteristics for that application. And this is where data management can be extremely helpful in driving the creation of these systems. And extending those operational data systems to capture that data, to manage that data centrally, and ultimately to make it accessible for AI and ML tools, different analytics tools, does drive tactical actions that can be taken to improve water stewardship and help implement more circular systems within your facilities. So in summary, Prasad spoke to the value of data management in driving efficiencies, making issues known to the operations teams and driving faster response time, identifying sources of variability or waste, and how that data can be made available to analytics to move from recognizing that there's a problem potentially after the fact or just before it happens, to actually predicting and anticipating these problems and optimizing these systems holistically. Applying digital tools to smart resource management or extending those existing operational systems that may already be in place on the plant floor to an organization's water and energy management initiatives can not only help to deliver improved efficiency and reduce costs, but also better sustainability performance. These capabilities are crucial to implementing circular systems in the water wastewater space and monitoring and evaluating their performance. So thanks everyone for your time. That's all Prasad and I have today. Thank you everyone for listening. We'll open the discussion for any questions that you may have.
All right, perfect. Thank you. We can go ahead and begin our Q&A. A couple of questions that I received were just regarding getting a copy of the slides as well as a recording of today's webcast, which, yes, that information will be provided on the webinar page. And we will send everyone an email with a link tomorrow when that information is ready and available. And then the first question, what are some of the challenges plants face to use their water/energy more sustainably?
So I can take that, and then Ben, feel free to add. I think the biggest challenge that we see in the industry is really the age of the systems that customers have, and just the human resources they may have to start to implement some of these newer systems. As you know, as we kind of talked about during the presentation, and as Ben kind of laid out the circular water practices, it does require some level of digitization that customers reach to. There are several water utilities that are at a significantly aging infrastructure, not just from a physical infrastructure and a mechanical infrastructure, but even the systems that they use today to operate those. I think there is a need to at least get that to a certain level, so that some of these advanced capabilities could be possible. And I think that's the number one challenge as we kind of move forward. Obviously, the choosing the right level of platform, making sure that the right practices are put in for data to be accessible to multiple folks who can contribute to it, could be the other aspect that the industry has to put in.
I would just add that the actual collection of the data is often a challenge, and often this requires additional investment in instrumentation to collect more granular data, to collect data in places that maybe aren't currently instrumented. And so, overcoming that hurdle is a challenge that we hear from our customers. And I think it's a challenge that is getting easier to address as the costs of those instruments decline. But this is often investment that customers in some industries are in different states of maturity. There are some industries or some even some applications in which kind of echoing Prasad's point about the age of these systems, the investments in the instrumentation needed to collect data with sufficient resolution and sufficient granularity, those investments haven't yet been made, and getting to the point where you have the instrumentation needed to feed the right data to modeling tools or analytics tools is crucial.
Great point, Ben.
Thank you. Another question we have from Simu: are there examples that adapted circular water practices in the USA? If so, how did they integrate detection sensors, algorithms, and all? Is human capacity a challenge for managing circular water practices?
Yeah, no, I think that's a great question. I think, there's certainly a degree in which the, kind of the expertise, we are talking about a kind of a rethink of systems that have been in place for decades and decades, centuries even. So, the expertise or the rethink of the current operating model is a key component of beginning any implementation or any consideration of how an industrial process could become more circular or could leverage secondary uses for the different streams. Give you an example that's really old to kind of illustrate that this isn't completely pie in the sky unfounded idea. This doesn't necessarily pertain to the water wastewater space, but collection mechanisms and reuse of containers is something that the food and beverage industry has been using for centuries. Some of you may remember the kind of the milkman model in which the product was delivered to the customer. That product was then used, and the container that held that product was then returned and refilled. So that's an example of increasing the utilization of the materials in the packaging, and really focusing on the service and the performance of the product for the customer. That's one example of circular system that's very old, and actually we're seeing a kind of a rebirth of those kinds of systems. I don't have an example that's U.S. specific in terms of circular water practices, but the integration of those sensors, as Simu points out, is critical, and I think that speaks to what I mentioned just a moment ago: the need to invest in additional instrumentation to capture data on the quality of the water streams that are exiting one process in order to pair it with the appropriate application as an input to another.
Yeah, and Ben, I'd like to add to that is what we're seeing in the US is also this phenomenon of municipal water utilities uh, getting aligned to what we call as investor-owned or public-private utilities, and as they start to get managed by these semi-corporate bodies, the drive towards this optimization and the drive to for these systems is increasing. So there are customers who are experimenting with IoT sensors out there, and there's no, to Ben's point, I think we may have examples in Europe more than in US. I think from a circularity standpoint, I think Europe is further ahead in terms of awareness and implementation. But we are starting to see that the efforts happen in US as well, as we see more and more customers ask us about these solutions.
Thank you. And then Jacob asked, can you address cybersecurity concerns in these digital processes? They are often cloud-based, not the sensors, but the computing.
Yeah, sure. And I think it's a fair concern. And I think in when I was trying to address the first question around challenges, I think a lot of the first thing that a lot of these water utilities have to put in is a cybersecurity framework, and in terms, and it's not just for these cloud-based systems, it's even for their control systems. I think it is just starting to become a mainstream effort where water utilities are implementing some world-class cybersecurity practices within their control systems as well. But as you start to think about the cloud infrastructure that these analytics run on, I think most of the cloud providers like AWS or Microsoft or Google, they have a government cloud which is highly secure, which is used by some critical government agencies as well. So those kind of cloud infrastructure um, adoption for utilities could be a highly secure way of executing some of these analytics. Um, I think the water wastewater utility is far away from getting into more of the virtual private cloud kind of a kind of an arrangement. I think right now, starting with like the government clouds that are offered as infrastructure might be a better way to start down this path.
Thank you, Prasad. We do have a couple more questions. How have your municipal customers overcome budget concerns when it comes to digitization or sustainability efforts?
Great question. So um, it almost always starts with a very focused use case on what problem the utility is trying to solve. And like the use case example that I gave around the pump, you know, having a focused effort around trying to drive um, the benefit of uh, putting analytics on that not only drives a faster ROI, but it also drives some tangible results that can be used for justification from a budget standpoint. It is a challenge, especially when you think about municipal water customers. It is definitely a challenge in terms of getting budget approved, and by the time, depending on the cost of the project, going out to bid, and the time it takes to get through the process, it is definitely a challenge. But I think we have found a lot of success, and these customers have found a lot of success in kind of dividing these problems into bite-sized chunks that could be done at a much lower cost, a lot faster, a good proof of concept that provides some necessary data, some business data, some benefits data to drive a much bigger project there.
Thank you, Prasad. And we have time for one more question. What are some immediate outcomes your customers have seen?
I'm sorry, can you repeat the question, please?
Sure. We actually have two. The first one, what are some immediate outcomes that your customers have seen?
So it's definitely like some of the use cases that I discussed. There are customers who have seen a reduced cost for the chemical usage that they have. They've seen a longer life on their pumps as they've been proactive in maintaining them based on what the analytic is telling them. The just the quality of the water, being able to manage it at an optimum level that drives the overall operational cost. So it has always kind of uh, there's definitely a psychosocial benefit as well, in terms of having a peace of mind in operating. But from a tangible benefit standpoint, it always has come to the dollars that the utility has to spend in either maintenance or either in the quality of water and things like that, right? So that's definitely been the primary factor and the primary benefit they've seen.
And I would just add
Thank you, Prasad. Oh,
I would just add one quick point is reliability and security for the users, the customers. This is a space that we see immense benefit from our customers in the water wastewater space. And it's related, of course, to all the things that Prasad has mentioned about improving uptime, improving reliability, predicting failures before they occur, driving more effective maintenance. All of those have a benefit to the energy that's consumed, to how the water is being utilized, but ultimately result in greater performance for the customer, the end customer being the user of the water or the utility.
thank you, Ben. So it looks like we have just one final question here before we close out. Is the public-private partnership PPP approach be a better way to leverage high-level knowledge and human capacity gap? And is there a similar practice in Europe?
So I would say um, the European water industry is definitely a lot more privatized than what we have here in the US. Um, I wouldn't say that it exactly solves for the human capacity gap, because again, public-private partnerships are like, these are corporate companies running, and these are not these are obviously run for profit. So there's always the balance between resources they adopt versus what they run. It is definitely the focus on, due to the profitability, there is definitely a focus on driving more optimization into the operation. So that is definitely there. There's a focus there to ensure that whatever they are operating is operated um, most optimally versus it being a more of a purely public utility. It definitely, I would say, from a knowledge or a human capacity gaps, just the trend of a lot of the engineering firms also becoming integrators into the water and the utility space. That is a big trend that will help towards solving for the domain knowledge or for the human capacity gap that we have today in the utility industry.
And thank you both. That's all the time that we have for questions today. So I'd like to just thank you for presenting to us today. Thank you to our sponsor, GE Vernova, and thank you to all of you attendees for attending today.
Hey, thank you all for attending, and thank you for hosting us.